So I want to begin our discussion with a type of memory that we've already had extensive dealings with. That's the device memory. And the device memory has what I would call grid scope. In other words, it's available to all the threads in all the blocks in the grid. And the device memory has application lifetime, which means that once you allocate it, it exists until the app exits or until it's explicitly deallocated. So it sticks around for a very long time. Now, we've seen the dynamic mechanism of allocating memory. So essentially, you call CUDA-malloc to allocate a chunk of device memory, and you then pass the pointer to that memory to the kernel that you want to execute, and you use CUDA-memcpy to copy to and from host memory, and finally you use CUDA-free to deallocate. But in addition to this mechanism, there is also an alternative, shall we say, mechanism, the static allocation mechanism, and it's kind of similar, but there are a few differences. So the idea is that you essentially declare a global variable and you declare it with the device keyword. And what this does is it kind of automatically allocates the memory, and it can even initialize it for you to use within the kernel. So once you've added this definition, you can just go into the kernel and you can reference, let's say, this sum variable here without having to do anything. And to communicate with the host, unfortunately, you don't get that for free. You still have to use CUDA-memcpy, but it's a variety of CUDA-memcpy. So functions CUDA-memcpy to symbol and from symbol, they actually allow you to copy to and from the host memory when allocating variables this way. And if you allocate a variable this way, there's also no need to explicitly deallocate. So there is no need to call CUDA-free. Now, unfortunately, this type of memory is the slowest and the most inefficient. So it's very useful to be able to have a kind of memory where each thread in each thread block can access arbitrarily read-write, but it's slow, and that's the reason why other types of memory exist to speed up computation.